All right, guys, let's speed through these notes. Pretty straightforward stuff here. So base angle theorem. If we have a triangle where two sides are congruent, what do we call that again? Isosceles. Good. So we have an isosceles triangle with two sides being congruent. That means the angles opposite those sides are also congruent. So in this particular picture, we see from the congruent markers that AB and AC are congruent. So consequently, angle B and angle C are congruent. Okay. And that goes the opposite way too. So you see the converse right after that. If two angles are congruent, that means the sides opposite them are also congruent. Okay, so this is just a tool that you can use when you are trying to either prove the angles are congruent or find missing angle measures or side measures, different things like that. One corollary that's in there is a triangle is equilateral if and only if it's equiangular. So if you use that base theorem 3 times, you can see that the only way to get an equilateral triangle is if all the angles are the same. So it's therefore equiangular. And remember, if and only if statements means it goes both ways. So equilateral only if it's equiangular, and equiangular only if it's equilateral. Okay, so let's think about that for a second. If you have an equilateral triangle, what does every angle in that triangle have to be? It does have to be the same, so what would it have to be? 60. Right? Because we know that the internal angles, the 3 interior angles of a triangle have to add up to 180. So if they are all the same, they would have to be 60. Okay? The sides obviously could be various lengths, but the angles of a equiangular, equilateral triangle all have to be 60. Okay? Alright, so take that information, and I want you guys to try to do 5, 6, 7, and 8. Okay, so 5, 6, 7, and 8 together with your groups. Go ahead. Alright, so let's talk through these. 5 and 6 should be pretty simple. Then we'll move our way to 7 and 8, which are a little more complex. Number 5, what do the congruency markers tell you this is? All 3 are congruent, meaning it's equiangular, right? And we know that equiangular also means equilateral, so all the sides have to be the same. So if one side is labeled as 31, then X has to be 31. Okay. Number 6. Each side labeled as 12 tells you it's what kind of triangle? Equilateral, which means each angle is 60, right? Because 60, 60, 60 adds up to 180. So that means 2x has to be equal to 60. So I divided by 2 on both sides, and x has to be 30. Okay? Even if you didn't know it was all 60, you could say, okay, that's 2x, that's 2x, that's 2x. So 6x equals 180, divide by 6, you still get 30 that way too. Okay? Alright, let's look at 7. Okay. Alright, so it looks like that bottom triangle is what kind of triangle? Actually, let me talk through this entire thing, okay? So if I first want to look at x, I see that because these angles right here are congruent, this is an isosceles triangle. So this one is also congruent with this one, okay? So that means x equals y minus 25, right? I don't know what y is, so let's move on to trying to find y. We'll come back to x. So y is labeled as one of those angles in the isosceles triangle. So I know if this one's y, this one has to be y. Okay? So what I don't know is this top angle right here. But I do know that this top angle right here is part of a 90-degree angle because it's labeled as 90 degrees. So in order to find this little piece, I need to find this big piece. So this big piece right here is a part of this triangle right here. Which, did you notice what kind of triangle this was? It's equilateral, which means it's also equiangular. meaning each angle inside of this triangle has to be 60. So this piece right here is 60. So if that piece is 60, that means this piece has to be 30. Okay, so once I know that that part is 30, I know the three angles inside the triangle are 30 plus 2 y's, right? A y in each one of the bottom angles. And that should be equal to 180. So 30 plus y equals 180. And now I can solve from there. So subtract 30 from both sides, I get 2y equals 150. Divide by 2 and I end up with y equals 75. Okay, so that's one piece of information I need. Now I need the x value, and in order to find the x value, I need to plug y in right here, right? So 75 minus 25 is 50. So that means this side is 50, which means, work your way around, this side is 50, it's congruent to this side, which is 50. This is congruent to this side, which is 50, so I know x has to be 50. Okay, any questions there? All right, let's look at 8. Okay, top triangle is what kind of triangle? Isosceles. And we know that from these two sets of sides being congruent, so that means this angle has to be congruent with this one over here. So I'm going to go ahead and label that one as x. So that means 40 plus 2 x's have to be equal to 180. Okay, subtract 40 from both sides, 2x equals 140. Divide by 2 on both sides, x equals 70. Okay? All right, the bottom triangle is what kind of triangle? Equilateral. It tells me that all of those are congruent. So that means that 2y plus 10 has to be equal to x minus y. And we know x is 70. So we go ahead and plug that in, 70 minus y. Okay, so now I can go ahead and solve for y. So I add y over to this side. I subtract 10 over to the right side. Whoa, what happened? So that's gone, I'm left with 3y equals 60. Divide by 3 and y is 20. Okay? Okay, any questions? Can I get a comfort level using isosceles and equilateral? Trying to find these kind of values. Comfort level 3210. Okay, good. Mostly 2s and 3s. Practice makes perfect.